Recently, very important news has emerged about Hubble Telescope, NICER Telescope, Roman Telescope, and TESS. The first news about NICER. NASA is planning to repair Neutron Star Interior Composition Explorer, an X-ray telescope on the International Space Station during a spacewalk later this year. It will be the fourth science observatory in orbit serviced by astronauts. In May 2023, scientists discovered that NICER had developed a light leak. Unwanted sunlight was entering the instrument and reaching the telescope's sensitive detectors. While the team took immediate steps to mitigate the impact on observations, they also began thinking about a potential repair. Savin Arsalmanian, NICER's science lead at NASA's Goddard Space Flight Center in Greenbelt, said, "The sunlight interferes with NICER's ability to collect viable X-ray measurements during the station's daytime. Nighttime observations are unaffected, and the telescope continues to produce incredible science." Hundreds of published papers have used NICER since the mission began. Blocking some of the light leaking in would allow us to return to more normal operations around the clock. Arsalmanian presented efforts to address the issue during a talk on Friday, April 12 at the 21st meeting of the High Energy Astrophysics Division of the American Astronomical Society in Horseshoe Bay, Texas. NICER is located near the station's inner starboard solar panels. From that perch, it looks out at the X-ray sky, collecting data on many cosmic phenomena like regular pulses from supermassive stellar remnants called neutron stars and light echoes from flaring black holes. Observing these objects helps answer questions about their nature and behavior and increases our understanding of matter and gravity. In 2017, NICER also demonstrated the use of pulsing neutron stars in our galaxy to serve as navigational beacons for future deep space exploration through a program called Station Explorer for X-ray Timing and Navigation Technology. The telescope has 56 aluminum X-ray concentrators. Each concentrator has a set of nested mirrors designed to skip the X-rays into a detector. In front of the concentrator lies a thin filter called a thermal shield that blocks out sunlight. The concentrator is topped by a hollow circular piece of carbon composite called a sunshade with 6 segments that resemble a sliced pie. The sunshade is designed to keep the concentrators cool in sunlight and protect the delicate thermal shields. After the light leak developed, photos revealed several small areas of damage in some of the shields, though what caused them is still unclear. Keith Gendro, NICER's principal investigator at Goddard, said, "We didn't design NICER for mission servicing. It was installed robotically and we operate it from the ground. The possibility of a repair has been an exciting challenge. We considered both spacewalk and robotic solutions, puzzling out how to install patches using what's already present on the telescope and in space station toolkits. After many months of consideration, the spacewalk was selected as the path forward." NASA's Hubble Space Telescope and Solar Maximum mission, as well as Alpha Magnetic Spectrometer, also on the station, are the only other science observatories repaired by astronauts in orbit. NICER's solution is straightforward. 5 pie-piece-shaped wedges will slot into the sunshades above the areas with the greatest damage and lock into place. The patches are designed to take advantage of an existing piece of astronaut equipment called a T-handle tool. The patches are currently scheduled to launch to the space station aboard Northrop Grumman's 21st Commercial Resupply Services mission later this year. Astronauts will complete their installation during a spacewalk, along with other tasks. NICER is an astrophysics mission of opportunity within NASA's Explorers program, which provides frequent flight opportunities for world-class scientific investigations from space, utilizing innovative, streamlined, and efficient management approaches within the heliophysics and astrophysics science areas. NASA's Space Technology Mission Directorate supports the SEXTANT component of the mission, demonstrating pulsar-based spacecraft navigation. NICER also collaborates in automated tandem with JAXA's experiment MAXI to rapidly observe stars and other objects that flare unpredictably, advancing scientific understanding of our dynamic universe. The second news about Roman. Engineers at Laris Technologies in Rochester, New York have combined all 10 mirrors for NASA's Nancy Grace Roman Space Telescope. Preliminary tests show the newly aligned optics, collectively called imaging optics assembly, will direct light into Roman science instruments extremely precisely. This will yield crisp images of space once the observatory launches. Joshua Abel, the lead systems engineer for the Roman Space Optical Telescope Assembly at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said, This is the pre-launch first light, our first time seeing through the entire telescope. We're excited to enter the next phase of the project. Each of Roman's mirrors had passed individual tests, but this was the first time they were assessed together. Engineers had to make sure light would move through all of the optics in a tightly controlled way, or else the telescope's images would appear blurred. Bent Ecombe, an optical engineer working on Roman's optical telescope assembly at Goddard, said, "The telescope's optics are crucial for all of Roman's future observations." In addition to the large primary mirror and the secondary mirror, 8 relay mirrors serve Roman's 2 science instruments. All 10 telescope mirrors need to be aligned to well within the width of a human hair in order to optimize the telescope's imaging quality such that Roman can fully achieve its science goals. The meticulous month-long alignment process involved a series of iterations to bring test images into ever sharper focus. Once the mirrors were all properly situated, technicians permanently locked them in place. 3 of the mirrors will still be movable in space thanks to actuators mechanisms that control the mirrors' positions, which will allow astronomers to fine-tune the alignment even further once Roman begins its observations. The IOA's vision test establishes a baseline for upcoming vibration and acoustic tests. Engineers will compare measurements from before and after those tests to make sure the optics will withstand the strong shaking and intense sound waves during launch. After that, the IOA will have a final eye exam, this time in vacuum conditions at its cold operational temperature. Materials expand and contract with temperature shifts, and Roman's optics will go from room temperature conditions on Earth to a frigid 9 degrees Fahrenheit in space. Abel said, "Our prediction of the small change we expect to see going from ambient to these colder temperatures is very important." The test will also measure the IOA's performance in extremely low pressure to assess how it will operate in the vacuum of space. Scott Smith, Roman telescope manager at Goddard, said, "The joint team from LARIS and NASA has fully achieved the goals of the test. The technicians and engineers have executed a successful optical test with precision and excellence while maintaining their commitments to schedule. The entire optical telescope assembly, of which the IOA is a core component, is expected to be complete and delivered to Goddard this fall." And next news about Hubble. Like boulders, rocks, and pebbles scattered across a landscape, asteroids come in a wide range of sizes. Cataloging asteroids in space is tricky because they are faint and they don't stop to be photographed as they zip along their orbits around the sun. Astronomers recently used a trove of archived images taken by NASA's Hubble Space Telescope to visually snag a largely unseen population of smaller asteroids in their tracks. The treasure hunt required perusing 37,000 Hubble images spanning 19 years. The payoff was finding 1701 asteroid trails, with 1031 of the asteroids previously uncatalogued. About 400 of these uncatalogued asteroids are below 1 kilometer in size. Volunteers from around the world, known as citizen scientists, contributed to the identification of this asteroid bounty. Professional scientists combined the volunteers' efforts with machine learning algorithm to identify the asteroids. It represents a new approach to finding asteroids in astronomical archives spanning decades, which may be effectively applied to other datasets, say the researchers. Lead author Pablo García Martin of the Autonomous University of Madrid, Spain, said, "We are getting deeper into seeing the smaller population of main belt asteroids. We were surprised with seeing such a large number of candidate objects. There was some hint of this population existing, but now we are confirming it with a random asteroid population sample obtained using the whole Hubble archive. This is important for providing insights into the evolutionary models of our solar system. The large random sample offers new insights into the formation and evolution of the asteroid belt. Finding a lot of small asteroids favors the idea that they are fragments of larger asteroids that have collided and broken apart like smashed pottery. This is a grinding down process spanning billions of years." Co-author Bruno Marin of the European Space Astronomy Center in Madrid, Spain, said, "An alternative theory for the existence of smaller fragments is that they formed that way billions of years ago. But there is no conceivable mechanism that would keep them from snowballing up to larger sizes as they agglomerated dust from the planet-forming circumstellar disk around our sun. Collisions would have a certain signature that we can use to test the current main belt population. Because of Hubble's fast orbit around the Earth, it can capture wandering asteroids through their telltale trails in the Hubble exposures. As viewed from an Earth-based telescope, an asteroid leaves a streak across the picture. Asteroids photobomb Hubble exposures by appearing as unmistakable, curved trails in Hubble photographs. As Hubble moves around the Earth, it changes its point of view while observing an asteroid, which also moves along its own orbit. By knowing the position of Hubble during the observation and measuring the curvature of the streaks, scientists can determine the distances to the asteroids and estimate the shapes of their orbits. Asteroids SNAD mostly dwell in the main belt, which lies between the orbits of Mars and Jupiter. Their brightness is measured by Hubble's sensitive cameras, and comparing their brightness to their distance allows for a size estimate. The faintest asteroids in the survey are roughly 1/40,000th the brightness of the faintest star that can be seen by the human eye. In 2019, an international group of astronomers launched the Hubble Asteroid Hunter, a citizen science project to identify asteroids and archival Hubble data. The initiative was developed by researchers and engineers at the European Science and Technology Centre and the European Space Astronomy Centre's Science Data Centre in collaboration with the Zooniverse platform, the world's largest and most popular citizen science platform, and Google. A total of 11,482 citizen science volunteers, who provided nearly 2 million identifications, were then given a training set for an automated algorithm to identify asteroids based on artificial intelligence. This pioneering approach may be effectively applied to other datasets. The project will next explore the streaks of previously unknown asteroids to characterize their orbits and study their properties, such as rotation periods. Because most of these asteroid streaks were captured by Hubble many years ago, it is not possible to follow them up now to determine their orbits. The last news about TESS. NASA's TESS has returned to work after science observations were suspended on April 8, when the spacecraft entered into safe mode. All instruments are powered on, and following the successful download of previously collected science data stored in the mission's recorder, are now making new science observations. Analysis of what triggered the satellite to enter safe mode is ongoing. TESS mission is a NASA astrophysics explorer operated by MIT in Cambridge, Massachusetts. TESS has been scanning almost the entire sky looking for planets beyond our solar system known as exoplanets. TESS mission has also uncovered other cosmic phenomena, including star-shredding black holes and stellar oscillations. NASA's TESS entered into safe mode April 8, temporarily interrupting science observations. The team is investigating the root cause of the safe mode, which occurred during scheduled engineering activities. The satellite itself remains in good health. The team will continue investigating the issue and is in the process of returning TESS to science observations in the coming days. TESS mission is a NASA astrophysics explorer operated by MIT in Cambridge, Massachusetts. Launched in 2018, TESS has been scanning almost the entire sky looking for planets beyond our solar system, known as exoplanets. TESS mission has also uncovered other cosmic phenomena, including star-shredding black holes and stellar oscillations. Thank you very much for watching. Goodbye.